Okay, so what's the first number you want to try?
Let's try 2.
Okay, so I'm going to have to erase the formula, but we still have it up on the computer screen in case we forget it. So, the pattern is, the next number is the square root of your number if that's an integer, and if it's not an integer, you just add 3.
So
Right.
we'll have to add 3.
Yeah, go to 5.
Okay,
We'll have to add 3 again.
all right.
Go to 8.
And add 3, go to 11. And 14.
Okay.
Then 17. And 20. And 23. 26. 29.
32.
Yep, 32.
Okay.
Go to 35.
38.
38. 41.
Okay. Well, let's stop here because we're basically out of room on the whiteboard.
So,
This just, well, it seems like here we're just adding numbers, and we're not seem to be hitting any. If the number is we're not hitting any numbers where our number n is a square.
Interesting. Okay.
so is 2 plus a multiple of 3 ever a square?
Ah,
Is our question.
okay. So starting with 2 leads to the question,
It's 2.
is there ever a square? So what if is there an integer? Is there an integer x such that x squared equals 2 plus 3?
So
That's our question. So that comes when we start with 2. Do we ever hit a square? So this is exactly the right question that you need to arrive at to help solve this problem.
yeah.
At least get part of the way to the solution of this problem.
So
So what do you think? What kind of question? What sort of branch of math do you think this is coming from?
maybe algebra.
Okay, there's a little bit of algebra. We need to write down the equation.
Let's maybe a little bit of number theory.
Okay, so there's some number theory here. And what are some ideas that you know about in number theory that might help us solve this equation?
So
What are any ideas you know about from number theory?
I mean, we know about primes and factors.
Okay, we know about primes and factors.
I mean, we could try to do something with the factors here, but I don't think that would help.
No, there's a different idea that you know about that's going to come into play here.
We're not really using anything from probability here at all.
No, you're definitely using something from number theory. And it has to do with remainders.
Like the the modular arithmetic.
Yeah, modular arithmetic is going to come into play here. So is there ever, this is saying that x squared is 2 plus 3n, so what's the remainder when you divide by 2? By 3, I mean.
2.
2, so is there ever a square that's congruent to 2 mod 3?
no, there's not.
How do you know?
Because there's always going to be a remainder when you divide by 3.
Why?
Well, it's...
Why can the remainder never be 2? For if you start with any number. What are your choices when you start with a positive number? Or positive integer? What are your choices for the initial remainder?
So you can have mod
Is it 0, 1, or 2?
for mod 3.
Okay, so for I, oops, I already used the number x. So we'll all use y. So y can either be 0, 1, or 2 mod 3. And what's y squared going to be? If y is congruent to 0 mod 3, y squared is going to be
It's going to be still just 0.
0. If
And-
y is congruent to 1 mod 3, what's y squared going to be mod
It'll-
3?
It'll... going to it's gonna go. I think it's gonna stay at 1.
Okay, it will stay at 1. You just square the mod.
And then
What about 2?
And that 2 will go to 1 because 4 mod 3 is 1.
So we'll go to 1. So we've just learned something.
so the remainder when in mod 3.
It
when
can't
you square
can't
it.
ever be 2.
Okay, so if we start with 2 in our problem, we're going to go 2, 5, and we're always going to get numbers that are 3n plus 2. And what's going to happen with our sequence? Are we ever going to hit a square?
No.
No, we're not.
So what does that tell me about these numbers?
So they're never gonna repeat. They'll just keep going up.
So if we
And,
start, yeah.
and also anything that's 2 more than multiple of 3, like 5, if you start with 5 it won't work.
That's right.
If you start with anything like 8 if you wanted to.
Yeah, any number in the sequence, if you start there, you just keep going up forever. So we just learned something. If you're 2 mod 3 at the beginning, then it never works.
All right.
Alright?